So I will talk about the biofeedback in clinical psychology, some of the modalities, and an example of a research that I conduct with my colleagues in cognitive aging. So first of all, I would like to state what is biofeedback. So biofeedback is it's an operant condition of the physiological state. So generally, what we have is that concept in which the operant condition is a behavior which the individual has their behavior changed by external feedback beyond his knowledge. That is, the person is not completely aware what is happening with his behavior. We can also say that's a kind of unconscious or automatic process. However, usually most of the people that pass through the biofeedback training get some awareness of their own physical states. Therefore, they have this ability to change for a different state and they can perceive this difference. So we can say that's not only a behavioral process, but also a cognitive process. In summary, we can say that it's a self-regulation of individual physiological state. So how does it work? Usually, the biofeedback works with a technological equipment that gives the information of some physiological state. It can be the respiration rate, it can be the heart rate, the brain waves, even the temperature of the body. And these technological equipment are able to process this information and provide or give such a feedback to the subject. And the subject, consequently, is able to change his state. So I will state some of the modalities and the applications that we have. We don't have only the galvanic skin response, respiratory or heart rate variability, and the EEG biofeedback. We also have some others modalities in biofeedback, but these three ones that I will talk about, it's the most common ones that we can use at the psychological settings. So the galvanic skin response, it's a biofeedback based on the assumptions that the stress situation changed the sympathetic system, and consequently we have this changing on the level of sweat. Usually when we are more activate in our sympathetic system, we sweat more. So the range is made by a very simple electrode that is put on the point of the finger, and the person has a response from the computer telling that she's more activate, so her sympathetic system is more activate, therefore she's more stressed or anxious, or she's less. For instance, we can have a high-pitched sound emitted when there is an increase of the sweat amount, and we can also have a bass sound emitted when we decrease the sweat amount. Therefore, we have a less activation of the sympathetic system. Consequently, we are being able to manage our stress or our higher levels of anxiety. So the galvanic skin response, it's a very simple application, very easy to wear and to use it and to manage this simple sympathetic response that we have, but which is a very good information about how distressed is the person. Another kind of biofeedback is the respiratory and heart rate variability. So this is a combination of two kinds of biofeedback. One is the respiratory biofeedback, which usually analyze abnormal respiratory cycles such as tachypnea or hyperventilation. And the other one is the heart rate variability that describes the oscillation between heart rate over consecutive intervals, which is controlled by our autonomous nervous system over the sinusoidal node. So the heart rate variability training, it's accomplished when the cardiac rhythm enters in consonance with or synchronicity with the respiratory rhythm. That is, when we inhale, most of the time we are activating our sympathetic system, and therefore we have an increase in the heart rate. But when we exhale, we have the parasympathetic system activate, and therefore we decrease our heart rate. And this increase and decrease cycle that we create when we respirate, when we have this healthy breath cycle, and especially when we exhale more than inhale, we increase our heart rate oscillation amplitude, which benefits our heart rate variability. And for that, we are going to be able to manage more our stress situations on the daily basis. And the form of neurofeedback that I will concentrate more my talk is the neurofeedback, which is the regulation of the brain waves activity using a technological interface that feedback individual about their neurophysiological activity. In summary, is the operant condition of brain waves activity by EEG. So basically what we have is we put some electrodes at the surface of the head in the scalp, and those electrodes, like in a regular EEG, will process the raw information of our neuronal activity. And this process, usually we're gonna use a very and software, and this software will be able to decompose this information, and we're going to have a baseline of how the person is, and we're going to state a threshold of what we want to achieve. I will give an example, which is better. So I want to increase the attentional capability of my subject. Usually I will gonna make a training at the sensorial motor rhythm at the CZ area or sensory motor area. I will put the electrode at that area, and the computer will give feedback to my subjects only when these subjects are able to increase his attentional process, increase this frequency, this band frequency of the sensory motor rhythm. So some examples of the clinical application of biofeedback in psychology is mostly to manage stress in anxious patients, to manage hyperactivity and attentional process in ADHD children or adults as well, and depression. So these three examples that I am giving are the most common protocols, and these protocols are very effective. They have very good results in the studies with the subjects in clinical population, and also we can apply some of these protocols to healthy individuals to learn to manage stress in high performance individuals like athletes or VIPs from companies. And we can also increase cognition ability, like the attentional process or working memory process, which is the example that I'm going to give about the research that we did. So me and my colleagues, we did a research in cognitive aging, where we train the working memory performance in healthy elderlies, especially because we know that changes in cognitions are expected to occur as individuals grow older, especially in the attentional process, working memory process, and episodic memory. These changes are associated with changes in our neurophysiological states, because we have the atrophy in white matter and gray matter. We have degeneration of synaptic degeneration, blood flow reduction, and neurochemical alteration. And most of these happens at the prefrontal cortex. So as active functions of those patients usually are very impacted with age. So since the late 80s and 90s, we know that older adults may benefit from cognitive training. And we have developed a lot of working memory training, which is a tendency to enhance cognition, because working memory is one part of these active functions, and it's highly demand cognitive ability in our daily basis. We can change our working memory or behaviorally or by neuromodulation. So the person can use games to train, like computer games, like Cogmat that we have. The person can try to learn a new language, or can learn a new instrument, musical instruments. All of these are good way to cognitive train our abilities. However, we also can make this by neuromodulation, and that's the proposition of the neurofeedback. So our hypothesis was that if the person has a cognitive decline that's natural from his, or a consequence of his older age, so the neurofeedback, which require a lot of attentional process, are able to change the working memory. So our methodology was, we conduct a study with 70 healthy elderly in order to increase the SMR activity centrally at the CZ area, which is the sensory motor area in the cortex, during 10 sessions to improve working memory performance. Our assumption was, as we use the working memory model of Badley, and this working memory model states that our central executive require a lot of attentional process. And as we know that the SMR training are good for increased attention, so we just use this attentional training to increase working memory in healthy elderly. It was an experimental placebo randomized study. We divided in 3 groups, which was a neurofeedback group, a sham neurofeedback, and a no neurofeedback. So we have people that have true neurofeedback training, we have people that have a simulation of a neurofeedback training, and we have people that didn't have any training. We also conduct an EEG a raw EEG for general cortex during the working memory task before the training and after the training to check for cortical changes. The working memory task that we use while the person was doing the EEG pre and post training was the delay matching to sample task, which is a task where the person has to see a picture at the screen, and then the person has a delay, and afterwards the person will see two pictures. And the target, the objective is to choose the picture that she saw before. We use a 15 seconds delay between pictures. Why we did that? Because for working memory for visual working memory, what will change our ability to keep the information in line is the amount of time between the information that we see one time and a second time. So the longer is the interval, the lower is the individual performance. And as we need to compare the training, we need that this task was difficult enough that we have a result that we can compare. So that's the screen of the training, an example of the screen of the training. So the person had the electrode at the CZ area, and the objective was to increase the sensory motor rhythm. So we had a baseline, and from this baseline of the person, we establish a threshold of 10% higher. So the person must increase 10% of her sensory motor rhythm in order to get the feedback. So that's the screen where I'm showing to you how it was organized, the training. So first of all, we have a pre-training where we did the EEG with the MTS task, and then the person has 10 sessions of neurofeedback, and afterwards the person had the post-training DMTS with the EEG. The sham neurofeedback were the person did a first session of a neurofeedback of her, and after we just replayed the same first session for the person during 9 other sessions. And the subjects that didn't do any neurofeedback just went to the laboratory to do the DMTS task and wait like 3 weeks, actually wait 5 weeks because it was the exactly time of the training. And after these 5 weeks, the person did the DMTS again. The results that we have was an increase in the working memory performance for the group that did the neurofeedback, comparing to the ones that didn't do and the placebo group. So the difference between the result was significant only at the neurofeedback group. Another thing that was interesting was that at the post-training results of the DMTS, we had that the sham neurofeedback and the neurofeedback didn't have a statistical difference at their scores. But they have between the no neurofeedback. So the neurofeedback and the no neurofeedback had a statistical difference, and the sham neurofeedback and the non-neurofeedback had a statistical difference, which means that our result really indicate that the neurofeedback facilitates the attentional process, which is critical for a good performance in working memory. But we can also say that the placebo group had a benefit, because they also have an increase on their performance at the post-training. But this performance was not as good as the neurofeedback group, which is a kind of a placebo effect, of course, and which indicates that the exposition of the technique is already sufficient to induce a positive change in the cognitive ability. That was our results from the EEG, the comparison that we have. And generally, we can say this, that the study showed to us that the higher activation in the pre and post training at the DMTS test demonstrates that the recruited areas associated with working memory was being recruited at the frontal and central, mainly in alpha and theta frequency band. But we can also say that the difference in activation at the pre and post training for the neurofeedback and the sham neurofeedback may be explained by these two models, because what we observed was that the sham neurofeedback that has an increase in the performance of the DMTS, they had a higher activation between trains. So what they did was to increase their activation in order to keep their performance, which is a crunch model by Herter and Lawrence. They propose that older adults tend to compensate their cognitive decline by increasing their activity, their neuronal activity. So we could saw that. However, on the other hand, what we had was that the neurofeedback group showed and lower activation between training, which means that at the post-training, they decreased their activation and they had a higher performance, which means that they didn't need to increase their activation to keep their performance. So they were able to manage their performance and even increasing higher, significantly higher compared to the first sessions without having to spend so much energy to do it, which means that they gain plasticity in that area that was being recruited because of the neurofeedback training, which is in accordance with the interactive model from Bellevue et al. So to conclude, I have to say that the training presented to you today has this aim to demonstrate how neurofeedback might improve working memory and benefit cognitive reserve in aging population. And also, generally, we can say that the biofeedback is an important tool to improve self-regulation in clinical population and provide the ability to manage psychophysiological symptoms, as well as we can use it in healthy population in order to prevent cognitive decline and also to provide personal awareness and helping manage stress situation. That's it. Thank you very much.